Good day and Assalamualaikum. First of all, thank you to our respected lecturer. I are Dr. Wan Emri bin Wan Abdul Rahman and all classmates for giving us the opportunity to present. So we are from the course MEC 640. Today, we would like to present our project based on industrial medicine and safety observation at AA 3D Technology SDN BHD. Our group is from AMD 5M1C. Let me introduce our team member. First, we have Muhammad Alif Omar bin Mazlan, Muhammad Hafi bin Zairul Hisham, Ahmad Bashir Ashraf bin Mustafa, Muhammad Aiman bin Omar, and me, Amir Shukri bin Muhammad Nasir. In this presentation, we will explain the background of the company, safety practice, hazard identification, and improvement suggestion, and other things. Now, let us begin with the introduction of the company. Okay, for this section, I will introduce AA3D Technology SDN BHD and their main service. AA3D provide a 3D scanning, CAD design, and 3D printing service. They focus on rapid prototype and small-scale manufacturing, which allow customer to test and improve products before mass production. The company offer high accuracy and customized solution, especially for complex measurement using 3D scanning technology. Before mass manufacturing, AA3D produce prototype to verify design accuracy, strength, and functionality. They are equipped with FDM and SLA and DLP 3D printer, which support large bulk volume and different material requirement. Besides 3D printing, they also provide laser cutting, laser marking, and machining service. In addition, AA Trading operate a training center offering hands-on workshop to enhance technical skill in digital manufacturing. Overall, AA 3D play an important role in supporting product development from design to prototype and small-scale production.
Additive manufacturing builds objects by joining material layer open layer from 3D model data unlike traditional subtractive methods like machining. We also know this as rapid prototyping since the technology initially focused on manufacturing prototypes, mockups, and sample parts. Thermoplastic extrusion is the most common 3D printing process widely known as FDM, even though Stratasys holds the trademark for that specific name. The printer works by melting plastic filament and extruding it layer by layer according to 3D data. As the material is deposited, it instantly hardens and bonds to the layer below. The LP shares the photopolymer chemistry of SL, but the laser with an arc lamp and TMD to project entire layers instantly. This makes the LP faster while delivering the same high accuracy, even though it still needs support and post-curing. Uniquely, a LP requires only a shallow resin burst, significantly reducing waste and operational costs. The choice between these technologies balances efficiency against quality. FDM uses plastic filaments to deliver fast, low-cost prints suitable for everyday needs. In contrast, the LP uses liquid resin to achieve superior surface detail, even though these precisions come with slower speeds and higher costs. And next is design concept. First, complexity is free. Designers can create internal geometries, lattice structures, and cooling channels that are difficult or impossible to produce otherwise. This allows for parts with optimized strength to weight ratio. And second, part consolidation. Multiple components of an assembly can be combined into a single 3D printed part, reducing assembly time and potential failure points. And the third is material anisotropy. The layered process makes 3D parts look stronger in some directions than others. Designers must align the part orientation with the expected force or split the model into multiple sections for ideal printing and assembly. And next is design choice and proper part orientation can eliminate or minimize the need for support structures, which reduce post-processing time and material waste. Tolerance and fit. Designers should use the causes tolerance that still allow the part to function. making the design compatible with a wider range of printers and reducing costs. Features like teardrop shapes for vertical holes and crush widths for press widths can improve accuracy and functionality. And then the speed and flexibility of 3D printing allow rapid prototyping, enabling designers to quickly produce and test multiple iterations to refine concepts before final production. And as we can see, the price influenced by size and thickness. Simple text or logo and quantity ordered. If bulk order, they will be cheaper per price. One-off will be slightly higher, and price also depends on high print time and detail level. More detailed, longer print lead to higher cost. Expensive uh, because include design works, multiple test prints, and accuracy matter for movement, not just for aesthetic. And next slide is choice of filament. For easy indoor or decorative prints, choose PLA and switch to PETG for outdoor projects that require better water and heat resistance, and ABS for extreme toughness and heat, but ensure you have enclosure to handle the difficult print process. To ensure the highest quality in our additive manufacturing process, we have implemented an accurate multi-stage quality control system. First, we start with material and process control. We only use certified materials kept in strictly controlled environments to prevent degradation. During the print, we don't just watch, we actively monitor critical parameters and use optical systems to detect defects in real time. Once the print is complete, we move to post-processing. This involves precise support removal and specific treatments like UV curing or heat treatment to lock in material properties. Finally, we conduct validation. We use advanced tools like 3D scanners and CT scans to compare the physical part against the original CAD model. We also perform functional testing to ensure the part meets performance standard. Throughout this entire workflow, we maintain full digital traceability to ensure accountability and drive continuous improvement.
For this slide, I will explain the main physical products produced by the company. First, the company produces a wide range of 3D printed products using both FDM and SLA or DLP printers. For FDM printing, they are capable of producing large scale parts with a build size of up to 1000 by 1000 by 1600 millimeters. These are commonly used for prototypes, structural parts, props, and also display models. For higher precision applications, the company uses SLA and DLP resin printers, which are suitable for small, detailed, and mechanical components. Resin printing provides better surface finish and accuracy, especially for functional parts such as mechanical components and autosys. Secondly, the company also specializes in reverse engineering and also 3D scanning products. Scanning is used when parts are too small, complex, or difficult to measure manually, or when replacement parts are expensive or no longer available. This process is also applied in customized medical related products, such as scanning human hands to design prosthetics or orthoses before fabricating them using 3D printing. Lastly, the company produces the laser cutting and engraving products. These are mostly customized items such as wedding gifts, decorative boxes, and signage. Laser engraving is also used to create logos and nameplates for events and marketing purposes. Moving on to the second slide, I will explain the other categories of products produced by the company. The company also focuses on producing prototypes for manufacturing. These prototypes are printed and tested first to check their functionality and design accuracy. If the prototype is successful, it can then be transferred to mass manufacturing processes such as injection molding. In addition, the company produces various creative and media related products. These include movies and also cosplay props, marketing display items, and staging structures with moving mechanisms, such as those used in events like in Anugerah Juara Lagu or AJL. They have also produced detailed models for exhibitions, including aircraft models with moving propellers and LED lighting for Lima Langkawi. And finally, the company also develops digital-based products. These include simulation applications and games such as a bowling simulator, as well as CAD design outputs created using software like Fusion 360 and SolidWorks. Overall, the company's products combine advanced 3D printing, reverse engineering, laser cutting, and digital design, allowing them to serve industrial, medical, creative, and also commercial applications.
Okay, next for this slide, we will discuss the problem and challenge at AA 3D technology. AA 3D operate a comprehensive 3D printing farm with multiple FDM and SLA and DLP printer running continuously. This increase exposure to heat, moving part, firm and electrical hazard. They also handle large bulk volume printing, which involve heavy component and manual handling risk. In addition, the company use laser cutting and laser marking machine, which may cause ice hazard, burn and fire risk if not properly controlled. The presence of CNC and lathe machining facility introduce hazards such as rotating part, sharp tool, noise, and flying debris. Since AA3D is also a training and learning center, many users may be student or beginner, increasing the possibility of human error and unsafe practice. There are also multiple computer workstation and workshop space, which may cause electrical hazard, ergonomic issue, and workspace congestion. Overall, the combination of multiple machine, user, and activity increase the need for strict safety management, proper training, and effective hazard control.
Next, we move to discussion. For this part of the discussion, I will highlight how the company's integrated workflow and quality practices contribute to high performance and customized production. First, the company integrates 3D scanning, CAD design, and additive manufacturing to deliver solutions that are both highly accurate and tailored to customer requirement. This seamless integration ensure that design data flow smoothly from physical measurement to digital modeling and finally to production, reducing error and improving overall efficiency. Next, FDM and DLP printing technologies allow the company to produce both large scale functional part and high precision resin components. This flexibility enables them to meet different product requirements from durable structural part to detailed and visually refined model. In addition, the application of design for additive manufacturing or DFAM improve manufacturability by optimizing part geometry, controlling tolerance, and minimizing unnecessary material usage, which lead to more efficient and reliable production. Furthermore, the use of PLA, PETG, and ABS material balance ease of printing, mechanical strength, and heat resistance based on specific product needs, ensuring that each product achieve the best possible performance. Finally, quality assurance and continuous quality improvement process supported by customer feedback and systematic inspection help maintain consistent accuracy, reduce defect, and drive continuous operational improvement, resulting in higher customer satisfaction and reliable product performance. Thank you.
And next, I will continue for continuous quality improvement, or also known as CQI. CQI in additive manufacturing is applied across 3D scanning, CAD design, and 3D printing to ensure accuracy, consistency, and defect reduction. In the 3D scanning stage, CQI focus on data accuracy and completeness through regular scanner calibration, standardized scanning distance and angle, surface preparation to reduce reflection, and verification of scan accuracy against physical measurement. In the CAD design stage, CQI emphasizes design accuracy and manufacturability by applying design for additive manufacturing, or also known as DFAM principles, defining proper tolerance and fit, and conducting design reviews and validation before printing. Simulation and virtual testing are used to identify and resolve potential design issues prior to production. And lastly, for the 3D printing stage, CQI improve consistency and reduce defect by standardizing material-specific parameters, maintaining calibrated equipment, monitoring the process, and performing post-print inspection and testing. Then we move to the next slide. And for the CQI implementation, CQI is implemented through consistent quality practices across 3D scanning, CAD design, and 3D printing. This includes scanner calibration and standardized scanning methods, application of design of additive manufacturing, DFAM principle, with proper tolerance control, and standardized print parameters supported by regular printed calibration and maintenance. And for the CQI benefits and monitoring, CQI performance is monitored through scan accuracy checks, defect tracking, dimensional inspection, and customer feedback. These practices improve accuracy and consistency, reduce rework and material waste, and enhance overall product quality and customer satisfaction.